All right, guys, we're going to jump into the Q&A session. So this would be Season 1 at PETV Presentation Season 1, Episode 12 Q&A session with Rob Avis. Rob just gave a great presentation, packed full of information, and I have some questions for you too, Rob.
Great.
So the first question comes from Rihanna. Rihanna says, where would I look to find the land use bylaws for my property?
Where are you writing from?
So I guess it depends on the country. And
Well, in the U.S., the land use bylaw is called something different. Generally in Canada, we're separate. I think you guys are the same in how you guys are divided, but like your counties and stuff, you guys use counties, right?
Yeah, we do.
So generally, each county is going to have their own version of a land use bylaw, and cities then generally have their own version of a land use bylaw within the actual city itself. And it's probably not going to be called that in the U.S., but it probably will. It'll use the word bylaw, but it might not use land use bylaw. So it's really going to depend on your jurisdiction. But generally, the first place that I go to if I'm working in a specific county is I'll figure out what county I'm in, and then I'll call the county office and ask them about their bylaws or their land use bylaw. And it's written in less than easy to understand language. So if you're not trained as a planner, and a planner is actually a professional degree, there are private planners that you can hire to help you understand what's possible. And if you hire one of those planners within your county, they're going to have a really good understanding of that particular land use bylaw. And so it'll cost you a lot less to have that analysis done.
All right, excellent. Next question, you answered in the presentation, but they're I think we're looking for a little more details, or at least your thoughts on it. Stephen asks, for the problem of finding a small enough wood stove, would a thermal mass stove not work to moderate the output? So I guess I'd like your thoughts on thermal mass heaters, thermal mass stoves, and kind of the restrictions and reasons why it hasn't blown up as much as it possibly could have.
Well, generally, most houses aren't built efficiently enough to build small enough stoves to make enough demand for them to actually manufacture them. There are some tiny stoves available. I'll get to the mass question in a second. However, if we're going to build a really airtight house, we need the stove to have its own air intake so that it's not drawing air from the house. And there just aren't that many options for those types of stoves yet. However, that's probably going to change in the coming years as the passive house movement starts to gain a lot of popularity. It's a really good question because this comes back down to how you design your homestead. And if one of the advantages that I have as an engineer that understands energy, and you can have this too after I make this comment, is understanding, so there's hyper efficiency, there's complete inefficiency, and then somewhere in the middle you can actually tune your house to some given criteria. So let's say, for example, the smallest wood stove that you can get is 20,000 BTUs an hour. You might actually, you might be able to design a house that only uses 12,000 BTUs an hour, but you might consciously derate it a little bit, because 20,000 BTUs is still not very much energy. You might derate it to 25,000 or 30,000 or 20,000 so that it facilitates your ability to be able to use a wood stove. Okay. Now, regarding the mass stoves, absolutely, mass stoves are going to help to regulate it. But ultimately, it's just like money into your bank and money out of your bank, heat in, heat out. If the stove that you use, with or without mass, is putting more BTUs into your house per hour than your house is losing outside, it's going to overheat it. And here's the consequences with overheating. One, it doesn't feel great if it's like 38 degrees or 120 degrees inside of your house. Number two, a lot of people don't think about this, but your wood stove, when it's running at full bore, can actually increase the air volume in your house by 13%. So you'll actually start to exfiltrate air through the walls. Now, if you're in a really cold climate, the air inside your house has a lot of humidity. And so as you start pushing that air out through the walls, you can create toxic mold. So that's something you got to think about. And then as far as like rocket mass heaters, yeah, absolutely. I love those things. I think the 6-inch rocket mass heater, though, from what I was reading, puts out like 40,000 BTUs. You can derate the barrel. You can change how the design of all of that so that it puts less heat out. But ultimately, it's important to understand how you're going to heat the system first, whether it's with thermal mass or not, before you finish designing the envelope of the house. And really high efficient homes generally have lots of thermal mass, so that will also contribute to the efficiency of the house too, whether it's on a stove or not. The thermal mass is probably a conversation that we could talk about for an entire show, but
yeah, there's for more information on rocket mass or thermal mass heating, what resources would you recommend specifically for that?
I mean, Yanto Evans' book is really good. It's a good first starting place. I know that the Wisners just put out another book. I haven't seen it yet, but I've heard really great things about it. I've got a couple of YouTube videos that are pretty popular on YouTube that talk about rockets. Donkey's Farm, is that still up? You know?
Donkey's Farm. I'm not sure.
I think it is. I'm probably not saying it right. I know the Donkey's right. I'm not sure if it's a forum or something else, but there's a website up. If you type Donkey rocket mass heater, there's users from all over the planet that basically are experimenting and changing and working with all sorts of different orientations for rocket mass heaters. It's a super rich site. I haven't gone to it for about a year and a half, but you can literally spend days on this website and not even get close to the bottom. And like guys doing the craziest of experiments. So I love rockets. I love fire. I'm a bit of a pyro. Depending on where I end up living, long term, not depending. I have a rocket now. I will always have a rocket going forward. But I love experimenting with that stuff. I think they're really cool things.
Yeah, and earlier on one of the stoves you had shown, there was, I think you called it a wall thermal.
Wall therm, yep.
Yeah, is that a German or a Russian engineered?
It's German.
Yeah, so originally those were a wall in the house with that was like brick or rock, and then on either side there was openings for that where the servants would load up all the food on one side of the wall, and then on the other side they would take it out to serve it to the guests that were in these wealthier homes, but they were extremely good at building that thermal mass. Correct? Is that the same kind of concept as that stove you were showing?
Yeah, that stove, it's super cool. Well, there's two stoves. I'm not sure. The wall therm was the black one that looked a little bit more modern, and it has a water jacket on the back end of it. So you can actually heat your domestic hot water, and you can heat all of your hydronic like in-floor heating as well. And then it also acts as an airtight stove, so it'll actually heat the space while it's running. And then what's really neat about it is you can actually derate it. So it comes back to the thermal mass question we were just talking about. You can actually surround the stove itself with brick, and it cuts the heat output from the stove itself down by 50 or 60%. So more of the heat will go into the water, which is what you want. And that one does approach that 20,000 BTU when it's fully derated. So more of the energy is going into the water for hydronic and domestic hot water. It's not a cheap device though. For that wall therm, the pump station, and the tank, you're almost $15,000 or $20,000. So it's I would say if I had 20 grand to spend, I'd put it into insulation first, and then into a heating system second. The reason being is that insulation has no moving parts. It doesn't need to have its chimney cleaned. It just sits there, and if it's the right type of insulation, I think that's another really important conversation. There's a lot of insulation I don't like. If it's the right type of insulation, you can know that your house is going to be well insulated forevermore, basically.
Yeah, I love the idea of using the ground tubing in a design into a house. What would you say if someone has an existing house and you're going in there to really make this thing as energy efficient as they could afford, or you know, like with the first steps, I would say, I imagine insulation would be, or blocking off those air vents or air ventilation areas in the house, and no, not all ventilation, of course, but you understand what I mean.
Yep.
Insulation, and then your heating source, I guess, would be second, and then you start looking at those ground piping.
Yeah, it's going to depend. I mean, it always depends, as you know. But for sure, anything that's losing heat is our first, cheapest, best return on investment. So windows, air leakage, insulation. It could be air tubes, but the thing is air tubes aren't going to give me the same level of resilience if they don't have a wood stove in their house, or some sort of electricity-free heating mechanism. Earth tubes won't give me the same level of resilience as a secondary heat supply. And I don't want to buy that wood stove until I've done as much energy retrofitting as I possibly can. Every property is a little bit different, and there's going to be different opportunities for each one. And that's why it takes a little bit of time to assess it on the front end. But you almost can never go wrong with insulation if it's of the right type. So recently, I'll just, because I keep saying this, I've seen a few properties in the last little while where ants have actually honeycombed out all of the expanded polystyrene. So people use polystyrene below grade, and ants are actually nesting inside of these things and degrading the quality of the insulation. I think we have a massive building envelope failure, a black swan, on our hands here in the next few years. And EPS is only being used more in houses. So I actually look for ants on the property before I make any recommendations about insulation. And if I see any sign of ants, I will not recommend a foam-based insulation. And the thing is it's that can change. Like, there might not be any ants when we build, but there might be ants. And, you know, when I'm done putting in food forests or water harvesting systems, the whole ecological dynamic might be different. So I think we have to be really careful with foam-based insulation.
Yeah, and I think the whole conversation is very important, especially right now, because there's so many houses on the market right now, and there's a lot of abandoned houses. We're not seeing as much building as we used to, and so I think that future building that happens is going to be greatly encouraged by the retrofitting that people do in their existing homes, or when they're buying an already existing property. When they start seeing those things in houses, then start wanting them in their own, and they're actually looking for that on the real estate. That's when I think engineers start, or we would see a great increase of engineers starting to add these systems into new buildings for the future.
Yeah, and like, I mean, I am an engineer, so I guess I can say this. Not all engineers and architects are created equal, and I think it's really, I think both of those professions have an incredible role to play in the future, but I think there's a lot of integrative sophistication that they can bring into the way that retrofitting or new build actually takes place. And so I guess what I'm saying is, if you're going to hire somebody like that to help you, ask them some hard questions. You know, ask them, have a little bit of, have enough information in your back pocket, do some research, read some books. Chris Magwood just actually created a new book called Making Buildings Better. It's an awesome book. If everybody read that book or components of it before going out and hiring architects, engineers, then I think people will be a lot happier with the product on the back end, and it would be a lot more resilient, which is really the whole point of this talk. Just be careful about who you hire, and I mean, that's one of the reasons we started Adaptive Habitat. Was we act as trusted advisors. So I have no connections to contractors, material suppliers, equipment, nothing. My clients hire me to represent their best interests, and that's it. And that's the other thing that I think is really important to mention in the building trades, is that a lot of guys have distributorships or lines on specific product, which is great. It's how it basically helps to cover the cost of their time. That's part of their profit margin. And I think that everybody deserves to make a good living. But if you're representing a certain product, whether it's insulation or a heat pump or something, you're biased to try and you're trying to fit. Sometimes you'll end up trying to fit a round peg in a square hole. And every house and situation and property has its own characteristics that should be considered before you say, oh yeah, you need a heat pump, or oh yeah, heat pumps are things that kind of drive me a little nuts up here, because generally, they're $30,000 or $40,000 to put in. They require electricity, massive amounts of it, and generally they're not designed to actually meet 100% of the heating load. So in December, January, and February, you're using direct resistance electricity to heat your house, and then you're using a heat pump for the rest of the year, as an example. So it's really important that people understand where those biases lie before they go and hire a contractor or an engineer or an architect. And it's worth, I'm biased in saying this because it's the service that I offer, but I think it's worth having somebody that can basically stand in your corner and help guide those decisions, because they're not always simple decisions, especially when building science and heating systems start coming into play. And you can end up kind of painting yourself into a corner that's not very pleasant if you don't get the right advice from the front end.
Yeah, the services you're providing are a great service that I wish everybody knew about and could and would obtain before going in and purchasing or remodeling or retrofitting their existing properties. So you service the Canada, all of Canada, I assume. You'll take any customer in Canada. Is that the same with the North America or any country, or do you have recommendations for other, like North America, or sorry, US, the US?
We'll go anywhere in the world, to be honest. I guess with the exception that if I'm working outside of my climate zone, then I'm probably not a good fit. But one thing that so the answer is yes. I go right across Canada. I go into the US and globally for that matter. But I think it's just worth talking to a lot of different people before. Like, a house is one of the biggest investments you'll ever make in your life, and it's really interesting if you look at kind of purchasing psychology with people. We are really good at buying bottles of milk and cheese, things that are like $5 to $50. We're really bad at buying $300,000 to $600,000 or greater than that things, because we might only do it once or twice in our lifetime. And it's worth having somebody else in your corner to make sure that you're making the right decisions. Like one thing that is becoming a really big problem is building science. So like mold in houses, and with all of these spec houses and infills that are going in, especially in cities, but also in the rural areas as well, you don't know what you don't know. And like the real estate industry doesn't really have your best interest, because they get paid. They don't necessarily benefit from getting you the right house, because they get paid no matter what. And like even building inspectors, some of them are really good. Some of them don't know what they're talking about. So it's really, really important to do your due diligence when you're doing this. And there's lots of great people out there that can help you. You don't need to hire me from Calgary to come down to the US to do this. Just do your homework and make sure that you're asking the right questions.
Yeah, especially with such a large investment. I think most people at least attempt to do this, but yeah, there are people out there that are just looking at the size of the place and how many rooms it has and how many bathrooms it has. All right, and let's move on to more questions. We have a next question is from Mason. Mason says, I'm interested in adding a Graywater system to my home. One of Rob's videos, I saw a 3-way valve that you can use to send water back to the grid during cold winters and switch it back to the garden system and whatnot in the summer. What is the name of that company that makes those products?
It's called, the commercial name is Jandy Valve. And generally I found them at hot tub suppliers, as weird as that sounds. I guess they use them in hot tubs. I found another company in Calgary recently. They sell water filters for pools and stuff like that. So like a pool supply, I guess, but they also do like potable water filters. There's really crappy versions of these, and then there's really good ones. And the one in my video is a really good one. It's about $50, and I'll just describe it to you so you know what you're looking for. But basically, has 3 ports, and the ports have sleeves in there, so you can either connect it with 1.5 ABS, which is the black plumbing pipe, or you can pull the sleeves out and move it to 2-inch ABS. And then on the valve body itself, where the valve comes out of the actual unit, there's a series of stainless steel screws all the way around the actual body. That's really important that it has that, because then you can change the porting of the actual valve itself. So because it has 3 ports, you can decide which ports it goes to. Basically, you can change the valve stem around to customize to your needs, essentially. There are some really crummy ones out there, and they leak. They're not very, very good. The question that I would return with is, what is it that you're trying to send out to the landscape? Because sometimes you don't need a 3-way valve. For example, like the laundry machine, you can literally just create an opportunity to put the pipe from the laundry machine into another pipe, and so you don't need a 3-way valve. Honestly, the best advice I can give to you is get Art Ludwig's book, or Brad Lancaster's book, Volume 2 from Brad Lancaster. So that's dryland harvesting, or water harvesting for drylands and beyond, or Art Ludwig, Creating an Oasis with Graywater. Both of them are incredible resources. They're also incredible people. And I'd also check out Art Ludwig's website. What is it? Graywater Oasis, I believe.
Yep, Graywater Oasis. Okay, so some people are a little lost on they got the product, but what can you just give like a brief overview of what we're trying to accomplish here? What is this system you're talking about? Or this?
Oh, okay, sorry about that. So basically, the 3-way valve allows you. So just imagine if you've got water coming out of your shower or your bathtub, and let's say it's on a 2nd story of a house. You can actually cut the drainage pipe coming out of the bathtub, and you can stick this 3-way valve in between, or in the cut that you've placed. So now you've got, should I screen share the internet on this?
If you want.
Let me just pull it up. But basically what it allows you to do is, let's see if I can bring it up. It allows you, oh yeah, that's great, perfect. Okay, let me just screen share this here. So these are Jandy valves here. They're 3-way valves with a valve stem coming out of it. And here's a good example of it. This wouldn't necessarily be for a Graywater system, but let's say that let's bring that up. Let's say that your wastewater is coming through this pipe right here. This 3-way valve allows you to send water either in this direction. Let's say that's towards the central sewage system, or maybe your septic field or something. And then if the valve is flipped in the other direction, you can actually send it out to landscape in another direction.
Okay. Yeah, excellent. All right. Yeah, it's simple. It looks like a simple system to do a lot of major change.
Yeah, these are the crappy ones here. There's the good one right there.
The never lube Jandy valve.
There you go. Okay.
Cool. Thank you. All right. Move on to the next question. Next question is from Errol. Errol asks, have you heard of worm farm septics, and what are your thoughts?
I have, actually. I just went to a on-site wastewater conference, and there was a guy, I think he was in Oregon, actually, and he put in a septic field and then inoculated it with red wrigglers, even though I think it wasn't necessarily to code. And it turned out incredible. He did it for a restaurant, and so they were putting a ton of grease down the drain. And typically, restaurant septic fields don't last longer than about 15 to 20 years because the grease particles will actually stop infiltration into the soil. So he put down a 2 or 3 foot bed of wood mulch. I think it was maybe fir, although I think hardwood would probably be better. Definitely not cedar. I wouldn't recommend that. And then inoculated it with a couple pounds of worms. And man, oh man, like I bet you that field was worth, because up here anyways, a pound of red wrigglers is $70 a pound. And 1 pound of red wrigglers will breed to 160 pounds in 6 months. That's about $11,000. So I bet you he could have harvested all those worms, sold them, and then built a new septic field if he wanted to, or put it into something else. But yeah, I have heard of them. I think that it's potentially a really good idea. I don't think there's a ton of research on it. Although there's a great guy up in Victoria. His name's Gord Baird. He runs a company called EcoSense. I should just bring that website up because it brings up two separate. Make sure I get it. Here we go. He has a Graywater worm system, and has been documenting it religiously for a long time. I just put it into the chat there, and all of his plans are available on there. You can check it out. So I suspect you could do. Actually, there's one more thing. There's a company out of New Zealand that builds a product called Biolytics. I'll give you that website too. Biolytics.
Just for the viewers watching, the website he had posted is eco-sense, sense.ca.
Biolytics. So you can take this, see Biolytics, there we go. This system actually runs entirely on worms, and it's a commercially available product in New Zealand. And you can look at their website and basically back or reverse engineer it. Essentially, you can take a rain cistern, fill it up with mulch, and put a sump. Basically, you're basically building a wicking bed, essentially, minus the drain. And so you build a wicking bed with a sump going down the middle, and instead of putting soil into it, you put in wood mulch, and you seal the whole thing off, and you can actually process black water that way as well. When I was at the Jordan Permaculture Convergence a couple of years ago, I got to meet with a guy named Bob Corker. He is New Zealand's kind of preeminent or best graywater, blackwater designer on the entire island. And he basically copies this system that I've just put up, biolytics.com. So yes, worms can be used for sure. Anytime you use a biological system to process your wastewater, though, you obviously have to be very conscious of the soaps that you use and all of the other products that you put down the drain. And there just aren't that many. The type of soap it's not biodegradable soap that you want. That will kill everything. It's actually biocompatible, and there's a difference. And there's just not that many options for biocompatible soaps out there. And so a lot of soaps are saponified, which is the process of making soap using sodium hydroxide, and the sodium will actually kill everything. You actually want soaps like Dr. Bronner's or Mountain Sky soap that's saponified using a potassium hydroxide. And then the benefit to you is you're not actually buying soap, you're buying fertilizer that happens to clean your hands, your dishes at the same time. So soaps that are biocompatible will work with worm systems or ecological septic. You have to be really careful about what you put down the drain.
All right, yeah, excellent. All right, next question is from Haley. Haley asks, could you give us the address for the recordings? Yes, you'll be able to find this recording on vimeo.com, and you can just search PETV or PETV presentations. Either one will get you there, or you can go to tv.permaethos.com. Next question is from an anonymous. It was an anonymous question. Would adding a chicken coop to the passive greenhouse root cellar be a possibility, or on-hand fertilizer and heating for the chicken's coop?
Maybe. And I kind of have two answers for this. Generally, livestock and greenhouses are a bad combination because the ammonia coming off of their manure will actually burn the plants. And so you have to be very careful. And the heat gain from the chicken might not really justify all the extra effort. If you're not the type of person to be cleaning it out on a regular basis, I've walked into so many horrible chicken coops. People just kind of get sick of moving manure. But I am the lucky. I'm lucky enough to have been able to hang out with a guy in Manitoba who is obsessed with chickens, and he figured out how to put greenhouses and chickens together. And he did this by sitting down and watching chickens for almost 2 days. And what he noticed was that chickens almost always defecate after they drink. So what he did was he put a chicken nipple on top of their perch, and that was the only place they could get water inside of the coop. And every time they would, and then he put a pan underneath the perch itself. So every time the chicken went up to get water, he or she would defecate onto a pan. And so all, like 95% of the manure got accumulated in this one space. And so he pretty much never had to change the wood mulch or the shavings inside of the coop because they didn't get manure. And because he was able to contain the manure so much, he was able to tack on a passive solar greenhouse on the front side of the coop. So maybe.
Yeah, absolutely. It depends. And I would say, as far as I find that as well, that people don't like cleaning chicken manure or cleaning up a pen. And to get around that, it's a great idea to try and create a system that relies on that manure that you want, something that's desirable, so that you're using all of that material for something positive that you look forward to, or as much as you can look forward to cleaning out those pens to enhance another system.
Totally.
Next question is from Oscar. Oscar asks, can you please comment on retrofit considerations as design constraints?
Retrofit considerations as design constraints. Totally. Okay, so I'm in a house right now that is not owned by me, actually. It's owned by my mother-in-law, and it's oriented north-south, so 100% in the wrong direction. So there's only so many things I can do to this house to make it passive. In fact, it'll never be passive because it's in the wrong orientation. So the best that I can do in this scenario, that's my constraint, basically. So what's the best that I can do given its orientation? Well, I can hyper-insulate it, which I did. And then I can add solar collection onto the surfaces that I have available. And so that can be things like photovoltaics. I have a solar thermal on this particular house, so most of my hot water comes from solar hot water, a solar collector, I should say. I can remove windows that aren't serving me, and I can add windows in where they will serve me. So basically, once you understand how a building, if you're talking about building retrofit, interfaces with your particular ecosystem, and that's going to be very much dependent on where you're calling from or where you're signing in from. Some ecosystems you're actually going to want to reject sun, like when you get down to Tucson or some of the more desert areas. Some climates like mine, where we have lots of sun, but gets really cold, we're going to want to harvest all of that sun. So it really comes down to the actual building science and understanding the restrictions or opportunities that exist within your ecosystem, and then designing to those restrictions or opportunities. I'm not sure if that answered your question.
Yeah, it does. I think that answers the questions pretty well. All right, guys, we are coming up at the end here, so we'll just take a couple more questions, but we're going to have to close it up. So the next question is going to be from Susanna. Susanna says, I would like to replace the insulation in my home, specifically in the attic. It is a half duplex condo, 39 years in the house. It's a 39-year-old house. They've been in it for 3 years. It has 3 levels, and it's about 900 square feet total. What insulation would you recommend? Also, what insulation would you recommend for a small attic in a garage or a single garage kind of area?
Okay, so whenever you get any kind of ambition to do insulation, if you're going to go much beyond what's already there, due diligence that I highly recommend doing is getting a building science person involved. So this is typically an engineer or an architect that has a degree in building science. Whenever you go beyond a certain threshold of insulation, you risk changing the vapor and heat dynamics of the house such that you can create an enormous problem. So it actually doesn't help you, it sets you back. So a good building science person shouldn't cost more than, if we're talking about attics, like $300, $400, even $600 for their advice, depending on what they do for you. But having said that, I'm a big fan of cellulose in the attic because it's so dirt cheap, and so it's a recycled building product, assuming you have no leaks in the roof and it's all sealed up and you've got proper ventilation up there. You can add, like, I think I added 3 feet of cellulose. I added so much cellulose into my attic that I actually had to cut plywood to span the cellulose over the rafters so I wouldn't push the drywall down. And it cost me $1,000. So I did it myself. I got completely covered in the stuff, but it just kind of sits up there. My 3 feet of cellulose that I put in 5 years ago is probably only like 2.5 now because it will settle over time. But attics are one of the most cost-effective things to insulate in your house, and it can improve, the sound characteristics of the home as well. I'm not 100% sold on cellulose in walls yet. There's a lot of people that do it and swear by it. I'm still a bit skeptical about it. I definitely would advise against blown-in foam.
Okay. Next question's from me. What are your thoughts on Earthships? Do you have experience with Earthships, and when's an ideal time for an Earthship versus when you should not think about it, having an Earthship?
Yeah, so I actually did an Earthship course with Mike Reynolds, and I think that Mike is a visionary in a lot of ways, because the things that I really respect about him are his his incessant nature to try and eliminate mechanical systems. So the whole structure is basically designed around firing mechanical engineers, essentially. I think that's a success. The thing that I would say about Earthships, it's a very personal, like living space is a very personal thing, and aesthetics is very important, and the way that space is designed is very important. The house that you're in right now, I would feel very comfortable in, just the way that it's kind of like chunky and rustic, and an Earthship is not really that way. And sometimes, like, again, it's a very personal, but like not having windows on my sides can sometimes feel a little bit like a prison, as an example. And so, I think that Earthships, I think you can fix that. I think that those types of things can be designed into the system. But my best advice to like which building style you should go after is to go and try, like, Airbnb is incredible. There's probably Earthships on Airbnb that you can go try out for $100 all over the US right now. Go try living in one for a week, and see if you can, if you like that kind of space. I think that we can learn an incredible amount from Mike Reynolds in the way that he thinks about problems and some of the solutions that he's come up with. I think there's also very pragmatic ways that you can get all the benefits of an Earthship without having to pound 400-pound or fill tires with 400 pounds of dirt using a sledgehammer. There's a guy in Colorado, I think he uses cinder blocks, so you don't get necessarily the ecological benefit of using tires because you're using concrete, but you can build this thing in less than a building year, and not have to have a full-time chiropractor or physiotherapist working with you to make sure that your body doesn't fall apart. Every building system has its merits, and you just have to tailor those merits, those pros, and you have to add up all those pros and cons and see if it aligns with that. Remember that goal statement I said at the beginning? That's really important. Now, if you are absolutely sold on an Earthship and you're not willing to look at any other building system, like this is your lifelong dream, my biggest recommendation to you is to I don't like slanted glass. That's like #1 design flaw. So don't put your front glazing on an angle, put it on a vertical surface. The reason being when you put glass on an angle, there's two big problems that occur. Almost every glass on an angle is going to leak. And so that might not be a big deal if there's just a greenhouse underneath there, but if that thing was built with wood, you're going to have mold and rot issues with that leakage potentially there. The minute you go vertical, you ameliorate that. And then the other thing that happens when you go vertical is you can put an overhang, and those are really easy to design, such that we can eliminate all of the summer sun. And it's much harder to get a big enough overhang on an angle, essentially. So the other thing too is that these angles were selected to optimize winter solar gain. But the other thing that accomplishes is it actually allows for too much sun to come in the summertime. And I've been in these Earthships in the summer, and they almost, unless you've got human intervention, there's actually humans in there moderating the climate, those spaces overheat. And so it's very simple to fix. You just move the glass vertically and you add an overhang to the system, and it solves that problem.
Excellent. Well, we're out of time. Rob, thank you so much for being with us today. It was an excellent presentation. We got a lot of great feedback. I'll be sure to send it to you, the poll results. And once again, guys, Rob Avis. Rob, one last question. Where should people go to find more information about you and and about what you've talked about in the presentation today?
Yeah, so you can find our website, virtupermaculture.ca. I write a weekly email about this type of stuff all the time, every week. It's non-marketing email about all the stuff we talked about today. And then our consulting company is adaptivehabitat.ca. There's not much content up there. That's just basically my Yellow Pages ad. And I've been running blogs for about 5 or 6 years, and all the YouTube channels, YouTube videos you mentioned. There's tons and tons of info on our website, all free, available. So I encourage people to check that out.
Yeah, head over to Verge Permaculture, get on that newsletter. It's a great newsletter, and there's no spam or anything. Rob does a great job. Thank you very much, everybody, for joining us today. You can head over to tv.permaethos.com for more presentations and previous presentations we've done. You can sign up for new presentations coming up. Next week, we have Erica Block coming to talk about Local Orbit, her company Local Orbit, which we're excited to have. I think that's a great process and system that can be put into place for our communities. Once again, this has been Rob Avis with us today. Great presentation. Thank you all again for being here, and enjoy your week.
Thanks, guys.